So far we've done lots of empirical formulae calculations, but what we're going to look at here is actually how we can collect the data from an experiment to work out the empirical formulae. So what we're going to try and do is work out the empirical formula of magnesium oxide. Now this is not a core practical, but in the specification it does name this, and it is tested almost as much as the core practical work. So it's really important you know how to do it, and certainly in class we would do this as a class experiment. So what apparatus are we going to use? So we're going to use a tripod to start with, and we're going to heat our magnesium in a crucible on that tripod. So there's our tripod, and we'll put a pipe clay triangle. Let's extend that down slightly. We're going to put a pipe clay triangle on that tripod. So we're not going to use a gauze, we're going to use a pipe clay triangle, and I'll show you one of those in a moment. Now on that pipe clay triangle we're going to put a crucible, and a crucible is a little ceramic dish, and in that ceramic dish we're going to put our magnesium ribbon. So let's quickly label that up as well. That's a crucible, and that's our magnesium ribbon. Now the important thing is we're going to take lots of measurements as well, using a top pan balance. We're going to need a top pan balance. You're going to need to know exactly how much magnesium we're going to use, and then we're going to need to know how much magnesium oxide is made, and from that we can work out how much oxygen, and they are the readings we need to calculate an empirical formulae. So, the readings, we're going to need mass of magnesium. Okay, we're going to need to know the mass of the crucible, because we're not going to be able to scrape all the magnesium oxide out at the end, so we're going to have to weigh the magnesium oxide in the crucible. So if we have the mass of the crucible to start with, we can subtract it from the mass of the magnesium oxide as well. So that's our next reading. Mass of crucible and magnesium oxide. And then our final reading will be our subtraction, which will be mass of magnesium oxide. So we're going to take the crucible mass off the crucible of magnesium oxide, and that will give us this last reading. And then we can draw that into a table quite easily with some lines, and it's probably worthwhile doing that to keep your books neat. It only takes a moment. And it's well worthwhile doing, because having a clear book makes it ridiculously easy to revise from having a messy book or a disorganised book. It's really not very easy at all. Now all these masses are going to be in grams, so we're going to write mass there, and it's going to be in grams. Right, let's get started with this practical. So the first thing we need to do is weigh some magnesium and put that into our results table. So there's our magnesium, 0.24 grams. Next we need the mass of our crucible. This is our crucible we're going to use here. I really should use a lid as well, but I just need to get this done quite quickly today, so it's not going to be as accurate as it should be. 19.26 grams, and we'll write that in our table as well. So just quickly fill these results in the table. So many students make a mess of practicals because they don't fill things in before they don't fill results tables in before they get started on their practicals. So we said our mass of magnesium was 0.24 grams, and our mass of our crucible is 19.26 grams. Okay, next thing to do is we need to put the magnesium ribbon into the crucible and start heating it. So to get this experiment started, first thing we need to do is get our magnesium ribbon nicely in that crucible. Now we really should have a lid on it, because when we heat it, it's going to burn, oxidise with the oxygen in the atmosphere. And some of that magnesium oxide might be lost if we don't have a lid. Having said that, I need to get this done quickly today, so I'm not going to put a lid on. We're going to need a roaring Bunsen flame, because to get that reacting, okay, it's going to need to get very, very hot. So the magnesium is very flammable, but we're not heating it directly with a flame, we're heating that crucible. So it's going to take a little bit longer to get going, that's why we need that roaring flame. So we'll leave that going. We'll know when it's gone, because the magnesium ribbon will turn to a white powder. We might even, if we're lucky, see it go. Certainly if we had a lid on, we wouldn't see it. We might, without the lid, we might see it. Although I might pause the video just rather than make it overly long, so we'll just come back to it in a few minutes once it's wiped out. So we can just maybe see that glowing slightly. I'm going to lift this up a little bit, and we might just be able to see what's going on there now. So that magnesium oxide is oxidizing. So now that's reacted, it's turned to magnesium oxide. We'll turn the flame off, let it cool, and then we shall weigh it again and get on with our calculations. So we're now ready to reweigh the crucible and the magnesium oxide. So it's cooled nicely, so we'll put it on the balance, and we've got 19.65 grams. So let's fill that in here now. So we've got 19.65 grams for the crucible and the magnesium oxide. So we want the mass of magnesium oxide. So to do that, we're going to subtract this value from this one, the mass of the crucible and magnesium oxide from the mass of the crucible. So in other words, if we take the crucible off that line, we're left with magnesium oxide. So that's what we're going to do, we're going to subtract the mass of the crucible. So 19.65 minus 19.26 equals 0.39 grams. So what mass of magnesium reacted with the oxygen? 0.24 grams. What mass of oxygen reacted with the magnesium? So what we've got figures for magnesium oxide. I'm just going to put that as MgXOY because we're trying to figure out what these numbers are. And we know the mass of the magnesium oxide is 0.39, so that's 0.39 in total. Now we know that 0.24 of that, 0.24 is magnesium. So the rest of it, the difference between 0.24 and 0.39 has to be the oxygen. So we're going to subtract the 0.39 from the 0.24, and that will give us the mass of the oxygen. So 0.39 minus 0. Do that again. It was 0.39 minus 0.24 equals 0.15. So we've got 0.15 grams of oxygen. Okay, so the empirical formulae. To do empirical formulae, we divide a bit of paper in half, just a little bit, and we write magnesium on this side. So, whatever the compound is, we write one part of it on one side and the other part of it on the other side. So it's oxide. So we're going to write oxygen here. We're going to write moles equals mass divided by atomic mass there. For magnesium, we're going to write moles equals mass divided by atomic mass for oxygen. Now, the atomic mass of magnesium is 24. The mass of magnesium here is 0.24. I don't need a calculator to work out that's 0.01. Mass here for oxygen, we calculated it here, 0.15 grams. And that's going to be divided by 16. The atomic mass of oxygen is 16 if we look at that on the periodic table. So we definitely need a calculator for that. So let's put this oxygen calculation into the calculator. We've got 0.15 divided by 16 equals, and that's not going to be a terrifically nice number. Let's just do this with it. And we can see it's 0.009375 equals 0.009375. Well, that's going to round up to 0.01, isn't it? Okay, so I think I'm going to put that into our calculation, 0.01. I've rounded that. And so we can now see that is going to be mg 0.01, O 0.01. And we shouldn't be surprised we've got a strange, quite hard to deal with number here, and rounding it I think in this case is fine because it is very, very close to that. And that then makes those two numbers to be identical. Neither of them is bigger, therefore the formula, the empirical formula, is MgO, because we're looking at the relationship between these numbers. Certainly when we do a practical in the lab, it's very rare for the numbers to work exactly. And sometimes rounding can help us get the right answer. Sometimes rounding gets us to the wrong answer. So we need to be a bit careful with rounding, and that's why repeating the experiment a couple of times would be good. But that's basically how we would do the experiment.